This video provides a summary of the videos that I have on my YouTube channel, which is aimed at teaching microcontroller programming at the register level. The YouTube videos are based on a university course and are suitable for both students and home hobbyists. We use the microchip AVR ATmega2560. However, if you are using a different processor, the techniques still apply. The videos are condensed into nutshells, and you can find the channel by searching for C-Ridge Education in the YouTube search bar. And the nutshells are divided into explaining what microcontrollers are, C programming, and the onboard device registers and how to program them. First nutshell is an introduction explaining microcontrollers, the ATmega2560, and the teaching boards that we use on the course. The course is a practical course with real-life examples in programming. Once we have described the code, I will write the code into the Microchip Studio and then download it into the Mega Pro board shown here so we can see the code running in real life. If we look here, we can see here is a live video of the Mega Pro board. I am running some test software. I can use this to test the ADC switches, LEDs, PWM, UART, etc. So we can observe the behavior. In this example, I'm going to look at the ADC, and then I can look at the pots. So pot 1 is up here, and we can see pot 1 variable changing. I review the C language. We look at low level and high level languages, compilers and interpreters. I look at C keywords and syntax, pre-compiler directives, variables, operators, selection and iteration control structures, functions and libraries. So we explain machine code, assembly language and high level languages, C keywords, variables, pre-compiler directives, data types, arrays, number representation, C operators, and then the control statements. I show programming techniques. I show how to develop a program. I compare structured versus object-oriented programming and how to code a microcontroller. And we look at structure and state diagrams, looking at how to draw them and coding examples. The example shown here is a stopwatch using a state diagram. We have the pseudocode, the state diagram, and the code from the state diagram. Similarly, we can do the same code as a structure diagram. We have the pseudocode here, the structure diagram itself, and the code from the structure diagram. I explain bit masking, how to set, clear, toggle and read a bit, and I give code examples. And so I explain in more detail, setting a bit, clearing a bit, toggling a bit, and reading a bit. Then I look at the ATmega2560 onboard peripheral devices. I give an overview for each device. I show circuits. I explain the registers and how you would use them in operation. I give coding examples, and then I give you coding exercises where you can try and solve some problems yourself. I look at the general purpose input-output systems, which is used for digital input-output. I explain how to use the registers associated with the system. I show the architecture of the registers and how they connect to the outside pin. I then go through and give example code for use in the GPIO. Then we look at the circuits, explain active high, active low, and I look at code debounce. I look at the analog to digital converter. We review ADC concepts. We look at the registers used with the ADC and how they interconnect, and then I give programming examples for using the ADC. I look at the analog comparator. I explain what a comparator is, the registers and how to program them. This shows the internal structure, and then I give coding examples how to use it. I look at the universal synchronous asynchronous receiver transmitter. I explain where you would use it. I show the data frame. I explain the registers and how to code them, showing the internal structure, and then I give coding examples. I look at interrupts. I then explain what interrupts are, interrupt service routines, interrupt vector tables, local and global interrupts, and I look at the libraries and functions. I then look at the external interrupts. I show the registers and how to program them, and I give coding examples. I then look at the onboard peripheral interrupts. In this case, this is a USART, and I explain how to use interrupts with these systems. I look at the 8 and 12-bit timer counters. I explain how the system works and how to program the onboard registers. I show how the timers can be used for real-time interrupts, square wave generation, pulse width modulation, how to control servo motors, and how to measure period and frequency. Giving example code for real-time interrupts, square wave generation, PWM generation, servo motor generation, and finally frequency and period measurement. I then look at the CPU systems to program the EEPROM, put the CPU into sleep, or use the watchdog timer, explaining the associated registers, the code for the EEPROM, the sleep modes, and the watchdog.